Our next topic and the last topic is vectors. Vectors. We talk here about vectors in space. In space, we are using 3 dimensions. We are using X, Y, and Z. X, Y, and Z. Every point P, it has 3 coordinates, X, Y, and Z. We are going to call the usual thing, the unit vector in the direction of X is I, the unit vector in direction of Y is J, and the unit vector in direction of Z is K. We say that every point, right, has 3 coordinates, X, Y, and Z, and therefore the position of any point OP equal XI plus YJ plus ZK. We used to use before X and Y, XI and YJ in the mechanics M1. Therefore we added the axis K and we called the unit vector in the direction, we added the axis Z and we called the unit vector in the direction of Z is K. Right. Now every point has a coordinate X, Y, Z. The length of the vector OP, the magnitude of that vector, is the square root of X squared plus Y squared plus Z squared. In 3 dimensions, if we have 2 points, point A, coordinate x1, y1, z1, and point B, coordinate x2, y2, z2, and you want to find the distance AB, then you are going to say the square root of x2 minus x1 square plus y2 minus y1 square plus the square root plus z2 minus z1 square. So for we added z2 minus z1 square. This is how to get the distance between 2 points. Of course, in 3 dimensions, there's nothing called gradient of a line. No. Therefore, what we are going to replace, we're going to replace, instead of a gradient of a line, direction of line. And what is the meaning of direction of line? Direction of line means any vector, right, in parallel to the line, any vector in the direction of the line. We call this the direction of the line. Any vector in the direction of the line, we call it direction of line. Any vector parallel to the line, we call it in the direction of the line. Now, in this topic, we are going to say the following. It is now very easy using vectors and using the idea of I and j and k is to add two vectors, to subtract two vectors, right? It's very easy because we are going to add the I with the I, the j with the j, the k with the k. Subtract vectors, the same thing. To get the vector, say the line in the direction of, say, and we have a straight line and we want to find the direction of the line, we get the vector joining the two lines. We know that if we need to get the vector AB, we subtract the vector OB minus the vector OA. For example, if the point A is 2, 1, and 5, and the vector B is, say, right, 4, and 5, and 1, then the vector AB is OB minus OA, which is equal to 4 minus 2, 4i plus 5j plus k minus 2i plus j plus 5k. We subtract to get 2i plus 4j minus 4k. Now, this vector is twice the vector I plus 2j minus 2k. Means the vector AB is in the direction of I plus 2j minus 2k. Now, the new thing in vector, which we did not take something similar before, is how do we multiply two vectors together? The multiplication of two vectors. In actual fact, there are, if I have a vector A and a vector B, and I want to multiply them, we could multiply them by A, right, point B, A cross B, right. And we say we will take here in the A level the dot multiplication only, because the dot multiplication result on a scalar quantity, while the cross multiplication results in a vector quantity, and this will be taken only by those who will study engineering. And therefore, we are going to learn how to multiply two vectors, right, the product of two vectors. And we call this product, we are going to call it, right, we are going to call this multiplication we are going to call this multiplication of the two vectors, right? The product of two vectors, the dot product. That what is applied to us here. The dot product, we call it the dot product. Sometimes called scalar product. And why it is called a scalar product? Because the product will be a scalar quantity. Just like exactly multiplication of force and displacement. Force and displacement, we get work, and work is a scalar, while force and displacement are vectors. Therefore, we say the dot multiplication is a scalar quantity. If this is a vector A, this is a vector A, and this is a vector B, and the angle between them is theta. The rule is that A dot B equal the magnitude of the vector A في magnitude of the vector B في cosine the angle between them. This is the dot product. This is how to multiply two vectors, dot product. This equation, very interesting. Remember that if theta is 0, then A dot B equal the magnitude of A for magnitude of B. But if theta is 90 degrees, then A dot B will be 0. Therefore, the dot product of any two vectors perpendicular to each other is 0. And this is going to help us, by the way, in order to prove that two vectors are perpendicular to each other. That we are going to multiply them dot product, and we're going to show that the dot product is 0. How to multiply dot product? If A is given as A1I plus A2J plus A3K, and the vector B is AB1I plus B2J plus B3K, we need to multiply them together. In this multiplication, we are going to need to multiply I and J and K by themselves. Therefore, we should know this fact. I dot I is 1. Why? Because I dot I is the magnitude of the vector I1. The magnitude of the vector I, the other one is I1. The angle between them is 0. Cosine 0 is 1. The answer is 1. And J dot J is 1. And K dot K is 1. And I dot J is 0, the same as I dot K is 0, the same as, right, J dot K is 0. Therefore, when we carry out this multiplication, A dot B, when we multiply these three terms by these three terms, some products we need to multiply each one by the three ones. Each one by the three ones. When we do so, we discover that one multiplication will have an answer and the other two are 0. And the conclusion is this, that A dot B is A1B1 plus A2B2 plus A3, B3. This is an important result. Whenever you are multiplying two vectors together, and they are given in terms of I and J and K, you are going to multiply the component I times the component I, the component J times the component J, and the component K times the component K. That's it. And if, by the way, the two vectors were perpendicular to each other, then we should get the dot product is 0. For example, now we are given the vector A is, say, 6i minus 4j plus k, and the vector B is, right, 3i plus 3j minus, right, 6k. What is IA dot B? Is 6 times 3 plus negative 4 times 3 plus 1 times negative 6. 18 minus 12 minus 6 is 0. Therefore, vector A is perpendicular to B. Therefore, we came to this conclusion that these two vectors are perpendicular to each other. One other thing is to remember that if there's a relation between the two vectors, if vector A is, right, for example, 6i minus 4j plus 2k, and vector B is 3i minus 2j plus k, we notice that vector A is twice vector B. This means vector A is parallel to vector B. Therefore, we know when our two vectors are parallel, and we know that when our two vectors are perpendicular. Parallel if there is a relation between them, and perpendicular if their dot product is 0. Therefore, it's very well known now, are very acquainted with when our two vectors parallel and when our two vectors is perpendicular. Parallel if there is a relation between the two vectors, and perpendicular if their dot product is 0. Now, notice the rule A dot B equal magnitude of A, magnitude of B, cosine theta. We can make cosine theta subject. Cosine theta equal A dot B over the magnitude of A في magnitude of B. This means this is a very interesting rule. If the two vectors are not perpendicular to each other, when we multiply the two vectors together, dot product, and the dot product is 0, they are perpendicular. If the dot product is not 0, they are not perpendicular. And if there is no relation between them, they are not parallel. Then can we know the angle between them? Yes. How? From this rule. Have an example. Vector A is 6i minus 3j plus 2k. and vector B is right 2I right plus J minus 2K. These two vectors, they are not parallel because there is no relation between A and B. And if we multiply them, A dot B, 6 times 2 plus negative 3 times 1 plus 2 times negative 2, we get 12 minus 3 minus 4. 12 minus 7, 5. The answer is 5. Therefore, if the answer is 5, now now the answer is 5. Then we know that these two vectors are not parallel and not perpendicular. Can we get the angle between them? Yes. How? We need to multiply them. We multiply them. We need to get the magnitude of each one. What is the magnitude of A? It's the square root of 6 squared plus 3 squared plus 2 squared. This will come out to be 7. And we get the magnitude of B. This will be the square root of 2 squared plus 1 squared plus 2 squared. We never put minus when in magnitude because we know already that the minus square is plus. We get 3. Therefore, cosine the angle theta between the two lines is 5 divided by 7 times 3. 5 over 21. Then we can get the angle theta is cosine minus 1, 5 over 21. And therefore, we are able to get the angle between the two vectors. Therefore, now we know very well what is when are two vectors, when they are parallel, when they are perpendicular, how can we get the angle between them? All of this is known. Now, if we got a question like this, what is it? A question say, given that A equal, the vector A equal negative 2I given the vector A equal negative 2I plus 5J minus 4K, and the vector B is 4I right minus 8J plus 5K. plus 5k. And what we are asked, we asked this question. We asked to find, this is a question, to find a vector which is perpendicular to A and B. We are going to assume, or let this vector we are looking for, that this vector is xi plus yj plus zk. Then this vector is perpendicular to A. If this vector is perpendicular to A and perpendicular to B, but dot product of this vector times A and times B is 0. This means negative 2x plus 5y minus 4z equals 0, and 4x minus 8y plus 5k, 5z equals 0. How are we going to solve these two equations together? We solve this equation together by trying to get rid of one of the unknowns. We can get rid of x. We get rid of x. When we get rid of x, we multiply the first equation, this equation multiplied times 2. Therefore, get negative 4x plus 10y minus 8z equals 0. And we add, we get 2y minus 3z equals 0. This means 2y equals 3z. We try to choose right whole numbers for y and z to make this true. We are going to choose that y equals 3 and z equal 2. This makes this equation true. We go and substitute this in any of the equations, say in the second equation, 4x minus 8z minus 16 plus 5 minus 8, minus 8, okay, right. We are going to substitute this y equals 3 and z equal 2 in the second equation. 4x minus 8y, and the y is 3, يبقى negative 24. Negative 24. Plus 5z, and z is 2, plus 10 equals 0. We got 4x equal 14. Therefore, x equal to 7 over 2. Therefore, x equals 7 over 2 and y equal to 3 and z equal 2. We like to make them whole numbers. We multiply by 2, give us 7 and 6 and 4. Therefore, this vector we're looking for is 7i plus 6j plus 4k. This is easier than the method of substituting one value for x or y or z and then trying to find the others. It is better that we get rid of one of the unknowns, then we get a relationship between y and z or any two between them, then we choose whole numbers for them, and then we get the third variable This is the this vector is perpendicular to A and perpendicular to B. You can check, make dot product between this and A and B. You find both dot products is going to be 0. Now, we are going to go to the main thing. The main thing in this topic is to get the what we call the equation of a line in space. Right. This is, in actual fact, is what we are really looking for, is how to get the equation of a line in space. Now, we make it similar to the case of the equation of a line in a plane. Let us say this is a line, and we want to find the equation of this line. We say even in plane that we assume that we have a point known. So I assume this point is known, point A, and its position vector is A. Now the difference is this. In a plane, the line has a gradient. Therefore, you can choose another point and get the gradient. But here, we don't have something called gradient. We have something called direction of line. This line in the direction of the vector B. What is the meaning of this? That this line is parallel to the vector B. To get the equation of a line is to locate another point on the line, say point P. Its position vector, we call it R. The vector OP equal OA plus AP. The vector OP, which is R, equal A plus the vector AP. The vector AP is parallel to the vector B. AP is a constant times the vector B. We are going to call that constant T, TB, where T is a constant. We can put the value of T, any constant. We will get the equation, the location of another point on the line. When T is equal 1, we get one more point on the line. T equal 2, another point on the line. T equal 5, one more point on the line. T equal -3, one more point on the line, and so on. And therefore, this equation gives us any point on the line. Therefore, the general equation of the line is in vector equation, R equal A plus TB. Let us have the important question. We are going to give you a line passing through 2 points A and B. Say the point A is 2 and -1 and 3. And the point B is 6, right, and 2 and -1. And we wanted to find what is the equation of this line. To get the equation of a line, we need a point. So we have 2 points instead of 1 point. Remember the same thing in the previous AS. Then we said we want gradient, and we can get the gradient from the 2 points. Now we say we don't want gradient, we want direction of a vector. What is the meaning? We want a vector in the direction of the line. the vector AB is in the direction of the line. Therefore, we get the vector AB, which is OB minus OA. We subtract them, we get 4I, right? Let us make, this is 3, okay, plus 4G, okay, and we make this 1 instead of -1, and 1 minus 3 is -2, okay. Therefore, we got the vector AB is 4I plus 4J minus 2K. The equation of the line, this is the vector B. This is the vector B. Although we have B means position of B, no. But we take it as a rule that we discriminate between them. B means the direction of the line. The direction of the line, we have the vector A could be A or B, but the vector B is this vector, means the equation of the line, the equation of a line could be R equal the vector A, which is 2I minus J plus 3K plus T times the vector, which is the direction of the line, which is the vector AB, which is 4I plus 4J minus 2K. Another answer could be possible is to take the point B rather than the point A. 6I plus 3J plus K plus T times 4I plus 4J minus 2K. Also, another possible answer could be 2I minus J plus 3K plus S times 2I plus 2J minus K. Here I used another symbol for the variable T, for the constant T. I can use a variable, say a constant S. Some other student can say to me R equal to the same thing, 6I plus 3J plus K, but say plus mu times, okay. Now, negative 4I, right, negative 4I, negative 4J plus 2K. What happens? This student, he took direction of the line rather than the direction of the line is the vector AB. He took it the vector BA, which is correct. This means whenever we write the equation of a line, there are different forms for the same equation of the line. The same equation of the line, but there are different forms. They have one thing in common, the direction of the line. This is the same as this, is the same as this. How can be this the same as this? A parallel trait. How can we say this is the same to this? It is parallel trait but in the opposite direction. No problem. Because a line has no direction. A line, I didn't say that the line is in the direction of AB. I just said the line passing through A and B. Somebody say its direction is AB, somebody say its direction is BA, is all the same, no difference. And therefore, you can use the vector AB or the vector BA, is all the same. Therefore, now we can know how to find the equation of a line. And as they say now, there are different forms to get the equation of the answer. And therefore, this means in problems, when we asked to find the equation of the line, we could be all getting different answers, but all of them are correct. All of them, they are different forms of the same line. One question which, say, relate to this now is this. We can be asked this question. Now, the question is, this. We are given two equations, of a line. R equal 2I plus 5J minus 3K, and the other line R equal, plus T times 6I minus 2J plus 4K. And the other line is R equal 8I plus 3J plus K plus S times 3I minus J plus 2K. And our question is this. Our question is, do you know that, is there any relation between these two lines? First of all, when we look at the direction of the two lines, the two vectors 6I minus 2J plus 4K, and the vector, the other direction, 3I minus J plus 2K, these two vectors parallel. 6I minus 2J plus 4K is parallel to 3I minus J plus 2K. Why? This vector is twice this vector. Therefore, they are parallel. Therefore, these two lines are parallel. The question is, are these two lines parallel? Well, are those two lines? It is two equations for the same line. Are they two parallel lines, or are they two equations for the same line? How to know this? We consider the first line R equal. We are going to write it in vectors form. 2, 5, negative 3 plus T times 6 minus 2, 4. By the way, this is an easier way to write the equation of the line. You have the option to write it with I and J and K, or to write it in column vector. But this is easier because we can collect terms, similar terms together. What do you mean? What are the terms containing I? 2 plus 6T, 5 minus 2T, negative 3 plus 4T. What do we call this form? We call this form the general point on the line. We call this the general point on the line. يعني any general point on the line is in this form. How are we going to show that? Whether these two lines are two separate, يعني two separately, right, separate lines, but they are parallel, or they are means they don't, in actual fact, they are some distance apart. Well, the question is that these two lines are exactly the same equation for the same line. How do we know this? We consider the point on the second line. The point on the second line, el point on the second line is 8, 3, and 1. We check whether this point is on this line or not. How do we check that a point is on the line or not? We equate the x with the x and the y with the y and the z with the z. And we find the value of t. Therefore we say 2 plus 6t equal 8. We get t equal 1. We equate 5 minus 2t equals 3. We get t equal 1. We equate minus 3 plus 4t equal 1. We got t equal 1. If we get the same value of t for the three equations, this means this point lies on this line. Therefore, the point 8, 3, and 1 on the first line. Therefore, the second equation is having a point in the first line and the same direction as the first line. This means the second equation is the same equation for the line, yani therefore the second equation is for the same line. And therefore these two equations are يبقى two equations for the same line. يبقى two equations for same line. This is how did we prove that they are not really parallel lines, but they are the same, the two equations for the same line, because we proved that the point in the second line already lies on the first line. This is very interesting, right, result. Now, we have another kind of question we have to know is when we have two lines, we wanted to know whether these two lines, we look at them, we see if they are parallel, if they are perpendicular, right. If they are not perpendicular, or they are not parallel, then we have another question. Will these two lines meet together or not? Because you can have two lines like this parallel and they don't meet. And you can have two lines perpendicular and they don't meet. And we have two lines neither parallel nor perpendicular and they don't meet. And we can have two lines nor parallel nor perpendicular, but they can meet. The question is to know whether two lines intersect or no. We have this question. We have, right, show that if these two lines intersect. The lines are R equal, right. The first line is 3i plus 8j minus 2k plus t times 2i minus j plus 3k. And the second line is R equal 7I plus 4G plus 3K plus S times 2I plus J plus 4K. The question is, look at the two lines. The directions are not parallel. Therefore, they are not parallel vectors. And if we multiply the direction of this vector with the direction of this vector, the directions only, a direction, vector B, direction, vector B, if you multiply them together, we are not going to get zero, dot product. Therefore, the two lines are not perpendicular. The question is, we wanted to find out what is the angle between them. To get the angle between the two lines, we get the angle between their directions. The directions of the lines, are. The first line, we call it its direction B1. 2I minus J plus 3K. B2 equal 2I plus J plus 4K. It is just a trend that we call the direction of any vector is B. So we call them B1 and B2. To get the angle between any two vectors, we have the rule cosine theta equal A dot B over magnitude of A, magnitude of B. Therefore, to get the angle between these two vectors, we need first to get B1 dot B2, dot product, 2 times 2 plus negative 1 times 1 plus 3 times 4. We get 4 minus 1 plus 12. We get 15. We get the magnitude of B1 is the square root of 2 square plus 1 square plus 3 square. Remember, we won't put the minus inside the square root. And this is 4 plus 1, 5 plus 9, 14 is the square root of 14. Now, B2, it is the square root of 2 square plus 1 square plus 4 square. 4, 16, 20, root 21. If cosine the angle theta equal to the dot product 15 over the product of the magnitude root 14, root 21. Now, we got the angle between these two vectors, right? Now, 15 over 2 the square root of 14 times 21. We get 7 root 6. Right. Then we say 15 over 7 root 6. Right. Now shift cosine. The answer is right. Shift cosine 15 divided by 7 root 6. Now we get the answer 28 degrees. Theta is 28 degrees. We have now the interesting question, which is, will these two lines meet together or they don't meet together? In order to find whether they meet together or they don't meet together, we get the general equation of the two lines, the general point of the two lines. The first line are equal in vector form, 3, 8, -2, plus t times 2, -1, 3. The general point is 3 plus 2t, 8 minus t, -2 plus 3t. We go and do the same for the second line, and we get the general equation for the second line. For the second line are equal. Right, the point is 7, 4, 3 plus s times 2, 1, 4. We get the general point is 7 plus 2s, 4 plus s, 3 plus 4s. We want to know whether they meet or not. If they meet, then the general point here, the two general points will be equal. This means the general point, the first general point, which is 3 plus 2t and 8 minus t and -2 plus 3t should equal 7 plus 2s, 7 plus 2s and 4 plus s and 3 plus 4s. When is a point equal a point? The x equal the x, the y equal the y, and the z equals the z. يبقى 3 plus 2t equals 7 plus 2s. 8 minus t equal 4 plus s. -2 plus 3t equals 3 plus 4s. This is the equation of the two. We are equating the two coordinates of the points. Right? Now, this is 3 equations in 2 unknowns. We are going to take only 2 of the equations, just 2 of them, and we solve them together. Let us take the first 2. How? We are going to multiply the second equation by 2. We get 16 minus 2t equal 8 plus 2s. And we write the first equation as it is, 3 plus 2t equals 7 plus 2s. And we add them. We get 19 equal 15 plus 4s. We get 4s equal 4, يبقى s equal 1. We substitute s equal 1 in the first order on this one, يبقى 3 plus 2t equal 4 plus 2, 9. يبقى 2t equals 6, يبقى t equals 3. We got t equals 3 and s equal 1. If we substitute t equals 3 and s equal 1 in the third equation, which we left it over, and the two sides prove to be identical, equal, then the two lines intersect. If we substitute t equals 3 and s equal 1 in this equation, and we prove that the two sides are not equal, then the two lines don't meet. Let us check now. What do we say here? This is called x, y, z. Therefore, we call this one z1. z1 equal minus 2 plus 3t, 3 times 3. The answer is 7. And z2 equal 3 plus 4s, and s is 1, is 7. This means the lines intersect. Where do they intersect? At the point this or this. Any one of them. We substitute either t equals 3 or s equal 1. It's easier to substitute here. Therefore, if we substitute s equal 1 here, we get 9, 5, and 7. And this is a point where the two lines will intersect. And therefore the lines intersect. And we already got the angle between them. By the way, where the lines intersect or the line don't intersect, we still can find the angle between the two lines by the method we explained earlier. And therefore we prove now that these two lines intersect. Therefore, we have a good idea about the equation of a line in a space. And the general equation is R equal A plus TB. And this is the main thing, right, we need to know about, right, vectors in space. And this is the end of the topic of vectors, and this is the end of the syllabus of C34 or C4 after we finish C3.